Hello, I'm Dave Messerschmidt, Emeritus Professor of Electrical Engineering and Computer Science at UC Berkeley. And this is a talk on ideas for strengthening the scientific foundations of SETi. This accompanies a paper that I've written, which is also available on this website, called Towards a Science of Interstellar Communications. I've been assisted in preparing this talk by my colleagues James Benford of Microwave Sciences and Ian Morrison from Australia. The goal of the ideas expressed in my paper and in this talk is to exploit existing methods and tools of both communication science and statistics to help focus SETi activities, the actual astronomical observations, on the most attractive searches, and to further advance the methods of signal discovery and identification used in SETi. We propose to do this by enhancing the scientific underpinning in several areas. One is to develop an enhanced understanding of interstellar communication, by which I mean design of signals for attracting attention and sharing information between different stars. And secondly, an enhanced understanding of the search process based on modern advanced statistical inference methods. And then thirdly, to apply advanced tools in statistical interference that are being developed today, which includes automated learning algorithms that develop quality methods of detection automatically without human intervention. So in what we're proposing here, there are three complementary initiatives. Of course, the most important is the SETi astronomical observations at the bottom. That's where the rubber hits the road, where the science objective is achieved. And that objective is to identify and interpret artificial signals of extraterrestrial origin. And the other things we propose here are in support of that. One is to develop what I call in the attached short paper, The Science of Interstellar Communication, which seeks to uncover universal properties of the environment for communication between stars and the signals used for that purpose, and to advance signal identification methods. Secondly, we propose a simulation environment to supplement the astronomical observations called Intercom. And the purpose of this would be to explore and evaluate and compare methods on an end-to-end basis, something that cannot be done in the astronomical observations or cannot be done experimentally, and to improve and understand the search process as well. All of these initiatives are complemented by the sciences on the left, communication, statistics, and computer science, which are the emphasis of the science of interstellar communication, along with physics and astrophysics and astronomy and understanding the environment for communication, and obviously the SETi astronomical observations are heavily weighted by astrophysics and astronomy. So the basis for an interest in the science of interstellar communication is major progress that have occurred in recent decades. Most of the SETi searches to date have been influenced by the very influential report, Cyclops report, back in 1970. But since that time, there have been huge advances in a number of areas which we seek to incorporate into the understanding of interstellar communication in support of SETi's astronomical observations. One is the fundamental limits in communications and how to achieve them, which provides a lot of insights into the kinds of waveforms to expect coming from an interstellar source, extraterrestrial source. based and influenced by the environment that the signals have to propagate through, and other environmental factors like RFI and the noise, sky noise from, for example, cosmic radiation, background radiation. There's also been tremendous power in the tremendous advance in the technology of high power transmission, giving us added understanding of fundamental factors of physics in such transmissions. Based upon pulsar astronomy and related astrophysics modeling efforts, been a tremendous advance in the understanding of the interstellar medium, both from a point of view of how it affects signals and from the point of view of mechanisms that cause these effects. There's also been great advances in the communication in the presence of large interference, which is important to SETi and observations because we have to deal with artificial signals of human origin as well as extraterrestrial origin. So, for example, for military communications or for radars, such as the radars that are appearing in automobiles on the highways, those systems often have to deal with interference that's much larger than the signals of interest. And we now know how to do that through the design of signal waveforms. In the signal statistical inference, including the learning algorithms, deep learning, and such things, are making very rapid advances these days and show a lot of promise for developing enhanced ways of discovering new signals without as much prior assumptions about the nature of those signals. So included in all these areas are many scientific insights. It's not just design options, but they're actually scientific insights telling us fundamentally what is and what has to be, and insights that affect the transmitter of extraterrestrial signals as well as the receivers of such signals. So the point is that these insights are accessible to both us and to an extraterrestrial intelligence, and that then provides very valuable information on what kinds of signals that we should be searching for. The environment for extraterrestrial communication is shown here, and the point of this slide is that there's two aspects to this environment. One is the origin under transmitter control on the left, which includes transmitter antenna and the interstellar medium, which the transmitter has to take account of in the design of the signals, and that leads to the interface, which is the point at which we observe the signal. That's where we observe the handiwork of the transmitter designers. And beyond that is factors in our own environment that are under our control or are well known to us, including the radio frequency interference environment. An important point is that the left-hand side that's under control of the transmitter is inaccessible to experimentation because we have no interstellar probes out there which are going to transmit signals for experimental purposes. So we are dependent upon the handiwork of physicists in telling us about transmitters and antennas and such, and the handiwork of astrophysicists in telling us about the interstellar medium in modeling that part of the end-to-end system. So in the paper which is attached, I have a number of interesting areas of study within the science of interstellar communication, and I won't bore you with details here, but rather refer you to the paper simply to hopefully motivate you to take a look at the greater detail in that paper, which is about 10 pages long. The One of the major recommendations of the paper is that we make more extensive use of computer simulation in support of the SETi activity. And this, of course, is nothing unique to this particular science, but in fact, both the design and various sciences use computer simulation extensively these days. It's becoming an entire new methodology within science, for example, in many areas. So we would like to see it more heavily used in this area for the purposes listed on this slide. One is to largely replace experimentation for evaluation and testing of end-to-end methods of communication. And of course, this is critical for SETi because there's no possibility of experimenting with the physical environment. We have to depend upon modeling and simulation. This it can be very helpful for exploring the complexities of this environment and the various alternatives that are involved. This is intended then to be complementary to SETi searching by and improve the probability of success in the SETi searching by helping to identify and compare the most attractive signal categories on an end-to-end basis. We assume that the transmitter designers have done this. They have looked at alternatives and decided on the most attractive alternatives to use, and so this provides us with valuable information about what to search for. It also allows us to explore different design search scenarios, such as different statistical techniques for detecting signals, and do this in a controlled environment where we have control over both the presence and absence of signals and the location of signals and the presence of RFI and such. So we can now test and quantify search strategies extensively before we deploy them into SETi search, which means that we have greater confidence that they're working properly and that they are working well. And this environment can also be used to train learning environments, which is learning algorithms, which is a new opportunity brought by the extensive developments in deep learning that's occurring in various areas of science. So for this purpose, we advocate creating a simulation platform, which we've tentatively called Intercom, for interstellar communication. The purpose of Intercom is to explore the inaccessible inner environment, the inaccessible environment of transmitter and the transmission through interstellar space, and also to explore transmitter limitations and their effects upon communications. It can therefore allow us to compare different end-to-end scenarios and different search techniques on a full end-to-end basis and evaluate their efficacy and effectiveness. And as I mentioned earlier, we assume that the transmitter has evaluated the efficacy of anything that they're using. That is, they've determined that it works, and they've also evaluated the effectiveness and decided that particular techniques work better than others, and we can reproduce that work in preparing for our SETi searches, and to also train statistical information inference engines in controlled environment of both signal and interference. The block diagram, this parallels the physical system that I mentioned before: transmitter, interstellar medium, the reception, signal interpretation, and various search scenarios, including libraries of standard models and functions, so that the amount of work in putting together a new simulation is minimal. And we envision this would be an open source set of software available to all, but with a governance process that determines what modules are incorporated into the system coming from a variety of sources. And we think it's very important that this have a centralized maintenance and user support to make it user-friendly and easy to use, and to save the time and effort on the part of various researchers that are using it. And importantly, the physical models would incorporate the latest results from astrophysics and pulsar astronomy to give us an up-to-date and the best view we can have of the propagation characteristics that we're having to deal with. Just shown an example of such a simulation environment in a different context, wind turbine modeling, but it uses a Simulink, which is based on MATLAB, and allows you to move around existing blocks and connect them up and run them and add blocks of your own, and then graph various waveforms and see what instrument the simulation to see what's happening. So this is the kind of software environment that we would envision being used in intercom. Besides what I've mentioned previously, some of the other benefits of investing in this intercom simulation platform would be to achieve a high return on investment by focusing the high-value astronomical instruments and facilities on the SETi science objective, which is to discover and interpret signals of extraterrestrial origin, and depend upon relatively low-cost simulations on standard computing platforms as the workhorse of exploration, evaluation, and testing. We'd also like to see a broader scientific community focused around SETi research, including, as we mentioned at the beginning, communication, statistics, computer science. And we think these have a lot to offer in terms of improving the chances of success in the SETi searching. But one of the problems that these groups have is, these disciplines have, is access to facilities for performing scientific research. And so the intercom is a facility which can be made available to all, and on which quality science can be conducted without having access to these instruments and facilities. So in conclusion, what we'd like to do with this science is to focus SETi searches on the science objective, which is confirming or denying the presence of extraterrestrial artificial signals, and to improve the chances of success in that activity. We'd like to raise the visibility of the communication statistical sciences in SETi, because we believe that they have a lot of insight to offer into what kind of signals to search for, and how to search for them. And we have proposed a software platform that will improve the chances of success by identifying the most attractive signal and search strategies from a huge universe of alternatives, which parallels what we presume is happening on the part of the transmitting civilization. And we'd like to do comparisons on an end-to-end basis, so that we're sure that we've incorporated all of the effects, including the interstellar medium transmission, which have a bearing on the kinds of signals that would be transmitted and received. And the platform, we believe, would pay huge dividends in terms of allowing us to employ more advanced statistical methods of learning algorithms in our searching methodologies, which requires that we have training opportunities based on an actual control over the presence of signal and RFI and such, which cannot be accomplished in any other way than with a simulation platform. With that summary, this quick summary, I hope that I've interested you enough that you would be interested in looking at the paper that I've written, about 10 pages, which plus some appendices, which evaluates all that I've talked here about in somewhat greater detail, and that's particularly the areas of investigation. And to mention also that I think that we've not been exhaustive here. Clearly, there may well be other opportunities that are outside of our knowledge or expertise, or we just haven't identified them. So we really think that it's an appropriate time to bring to bear some thinking in the larger realm, and not only the ones that I've discussed, about how the SETi activities in the future can be better than the SETi activities in the past, and be more effective. So thank you very much, and if you have any comments or suggestions,